The difference between alarming and catastrophic. The Cascadia Megafault has one especially deadly section, a new map reveals. The Cascadia subduction zone is more complex than researchers previously knew. The new finding could help scientists better understand the risk from future earthquakes. The Cascadia subduction zone has the potential to rock the Pacific Northwest and British Columbia with devastating earthquakes, and now a closer than ever look at the megafault structure reveals it is segmented into multiple major regions. These regions might rupture individually, or they could all unleash a massive trembler at once, but the findings indicate that the experience of a quake might be different in each zone. It requires a lot more study, but for places like Tacoma and Seattle, it could mean the difference between alarming and catastrophic. Study co-author Harold Tobin, geophysicist at the University of Washington, said in a statement. In many subduction zones where oceanic crust grinds underneath lighter continental crust, small and medium-sized earthquakes are common. These mini-quakes give researchers information about what the hidden portions of tectonic plates look like and where various faults are located. But Cascadia, which stretches 600 miles from northern Vancouver Island to Cape Mendocino, California, rarely throws off small quakes. Lead author Suzanne Carbot, a marine geophysicist at the Lamont Doherty Earth Observatory at Columbia University, said. So the best view scientists had of its structure came from research in the 1980s that used shipboard instruments to send small bursts of seismic waves into the crust and then record the returning waves to make images of the subsurface. Today's instruments are much more sophisticated, Charbot said, but no one had done a repeat study of the region. So in 2021, the researchers behind the new study gathered new seismic data along the fault. And the data covered 560 miles of the boundary between the continental North American plate and the oceanic plates. We want Juan de Fuca, Explorer, and Gorda plate, all of which are plunging beneath North America at a rate of 1.2 to 1.6 inches every year. That's pretty fast. The data revealed that as the oceanic crust is subducting or driving down, it's also breaking up. And now that we have actual information spanning the whole region, we know that the fault surface is much more complex in its geometry than the picture we had from very old data, Carbot said. The fault is split into 4 major segments. The researchers found one begins off of Northern California and extends to Cape Blanco, Oregon. The next extends northward from Cape Blanco to Alaska Bay. And here the researchers saw a lot of slip or movement of the two sides of the fault against one another. The next segment extends north of Alaska Bay to the mouth of the Columbia River. So finally, there's a large and important segment stretching from southern Washington to southern Vancouver Island, and here the plates come together as a flat, shallow angle, and there is a lot of area of contact. The size of an earthquake directly scales to the size of the area that ruptures, Carbot says. This means that the southern Washington to southern Vancouver Island segment is the most likely to give off a major earthquake. The Cascadia subduction zone last generated a major earthquake in 1700. There are no written records of the event from the time, but drowned trees and a mystery tsunami recorded in Japan reveal that on January 26th of that year, a magnitude 8.7 to 9.2 earthquake shook the region. That must have been, of course, basically what we had in Fukushima, right? Researchers don't know if the 1700 earthquake was caused by the entire fault rupturing or just one segment. The new understanding of the fault's geometry should help scientists better map the hazards from the next Cascadia quake, Carbot said. This includes not only potential shaking along highly populated regions such as Vancouver and Seattle, but also tsunami risk along the coast. The segmentation means you can make more informed predictions from how the patterns of shaking might vary, Carbot said. The findings were published Friday, June 7 in the journal science advances. This is by Stephanie Pappas on Live Science. Please leave your comments and thank you for your support. Finally, support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.